All right, so the issue we went over was people with disabilities or people that struggle with crowds can have anxiety and they can struggle with maneuvering um, in certain spaces like malls. And our project intends to improve this experience with a path density heat map that finds the best path for them. So we have an AI model that reads camera footage to detect how dense the crowd is and creates a shade of red that is stronger when the area is at a higher density. The user can then enter their current location and where they want to go to through command prompts, and a path will be drawn for them, and then the map then displays on a simple website that updates every time the project is run. And in future development, the path will follow walking bounds and find a path of least resistance and avoid prompting through the command line.
So for now, we're going to demonstrate how this will work roughly. So what we're going to demonstrate is show you a picture of the representation of Easton Station here. We had to randomly generate images for each of these streets because we couldn't get actual footage from Easton. But you'll see that, and then you also see the same path drawn on screen. So here, if we run this, we'll say we want to go from entertainment A to dining to B, and you'll see. So this is going to take longer than it would in real life because it is generating the prediction for every single one of the fictional cameras. And as you can see here, it's somewhat crowded, but not entirely. So if we go here and reload the image, we see that Easton Station is represented by a very low shade of red, whereas other places updated to change and be higher shades of red because their fictional cameras indicated that there were a lot of people there. This will help people maneuver around so so people in wheelchairs don't have to go through high density areas that might be harder for them to traverse. And for anybody who has a fear of crowds, it will allow them to see which path they can take to go without going through such crowds.